So, hi everyone. Today I'm going to discuss a problem about customer churn prediction about in telecom industry. So, what is churn? Churn prediction detecting customers who are likely to cancel a subscription to service. Churn is a problem for telecom companies because it is more expensive to acquire a new customer than to keep your existing one from leaving. So, when go to the Google color. So first of all, import some necessary libraries. Then import the dataset pd.read underscore csv. Then data head. This is the data. Customer ID, gender, senior citizen, partner, dependence, tenure, phone service, multiple lines, internet service, online security. That's some various columns here. There are 21 columns and 7043 rows. So this is a column. So first of all, replacing all empty space with none values. So for that, first of all, list the empty columns and write some Python code for I in empty columns. Data I replace space value with none, blank value with none. So data info. So there is some missing column in total charges. So here is 11 missing value in total charges, and here you see tenor column is 0. For these entries, even the monthly charges column is not empty. Let's see any other 0 here. There is no additional 0 here, so drop that 0 rows from tenure columns. So now the data safe is 7032 and 21 columns. So convert some string value, yes or no, to 01 in churn column, no to 0, yes to 1. So here's some value count or online backup. Here's some churn value count. There are that much of not churn 5163, not churn 1869 churn. So it's a imbalance data set. So plums 73.4%, not churn 26.6%. People are churn. So some plot for numerical columns and see the distribution, kernel distribution estimator. So there is some finding. Recent clients are more likely to churn. Clients with higher monthly charges are more likely to churn. Tenure and monthly charges are probably important features. So some numerical column and here some plot. Total charges. Here's some plot. So the monthly client doesn't seem to be such big drive of churn, but we can see 75% of churners pay between $60 to $100 a month. One important was we can see here the plot of 50% churners leave the company before the first year goes by. So here's the scatter plot. So categorical features are this. Visualize the categorical features. The soft plot on all the features are here. So there's a simple Python code also here. So it depends on stack plot by some simple Python code, and here some visualization. They define the stack bar chart. It's also cross tab and see the distribution of data here. So here's I plot some cross tab, phone service, multiple lines, internet service, and see the churn and not churn. So here also the some cross tab. Here check for outliers in numerical features. So numerical tenure group, monthly charges and total charges are the numerical features. So I check your outliers by quantile method. So there is no outliers. So let's go to the feature engineering part. So here the correlation plot, correlation and then data drop total charges as the correlation is high with respect to the monthly charges into tenure graph. So I drop the total charges column. So the tenure graph distribution and the counts here. So I write a function that reduce the data complexity and make 5 groups as per the dataset. So is if tenure group is greater than or equal to smaller than or equal to 12, then it is 1. In greater than 12 it's 2, greater than 24 it's 3, 24, and smaller than 36 is 3. So here data, and greater than 48 and smaller than 60 return 5, else return 6. So the value count, tenure group value count. So I drop the existing tenure group as a new tenure group column is created. So the counter plot about the tenure group and use John here. So as you see, multiple lines and phone service do not add any value. No model having similar churn rate. So I'll drop it. So I'll drop it. So here is a function that converts no churn to 0 and churn to 1. So I create some target variable x, I drop churn column, and y I keep the churn column. So trend is split here. The feature selection, I select the feature as with chi-square test. Chi-square test here have two values. One is f score and the p value. So as for p value, I rank the features. So here are the features as for p value. So then is correlation analysis. Correlation analysis, I apply only the x trend data and I drop the highly correlated feature. Here threshold is 0.9 and I drop the features that have more than 0.9 correlation value. So I drop them. Also I had some kind of mutual info index for see the feature importance. So it is scaling the data. The min max color basically scale the data between 0 to 1. So define the function for model evaluation matrix. So first with this function evaluate the matrix, the feature weight classifier, and this function, this Python code is a function that plot confusion matrix of a classifier and accuracy score, and this function plots the ROC curve and AUC curve. As per its imbalance dataset, basically it's required ROC score or confusion matrix. Also plot precision and recall curve and F1 scores. This is the Python code. So oversampling method. So I here oversample data use of smart atomic library. So atomic library basically oversample data. It here first of all the data count is 4125 for not churn, 1500 for churn rate, and is reduce the not churn data into 3943 and increase the churn data to 2705. So here's the random forest classifier. For hyperpermanent tuning, I give some value here and use a random grid search CB. Use a grid search CB here, and the best parameters are here, and I classify random forest prediction option, and this is the confusion matrix. We basically focused on recall value here. So the ROC curve for train data is 0.92. For ROC curve for test data is 0.82. And it's confidence matrix. And is the ROC curve and the precision recall curve. AUC score is 0.83. F1 score is 0.55. And AUC precision recall score is 0.62. So also here is logistic regression code. Also I applied various classifier here like risk classifier, dysentery, naive, wagging classifier, XGBoost, light GBM, multi-layer perceptron, ADA boost, gradient boosting, CAT boost. Here SBM gain is required scaling data because it depends on the distance bit point. So here is all score. That's for all score. Also I applied a voting classifier. So thank you.